everybody. It's a respected principal sir of Buxar, Government Engineering College Buxar. So today my topic is recent railway
Good
track.
afternoon to everyone. In this session, this is session number 12 of this FDP, and we have our speaker, Mr. Rakesh Kumar Sahu, Senior Section Engineer, North Jalpaiguri, North Frontier Railway. He has done his BTech in 2010-2014 batch from Motilal Nehru National Institute of Technology. And after that, he has done his MTech from IIT Guwahati. Now he has also served in a project and completed the project Araria Galgalia New Line project. He has recently completed. He has a vast experience and knowledge on Indian railway tracks, and nowadays so many railway accidents are happening. So he can give us few insights about these aspects of the railway. And because railway is a very essential part of this society and for infrastructure of the country. So let's hand over the session to Mr. Rakesh Kumar Sahu to present his view. Rakesh sir.
Thank you, Dr. Jitendra sir, for such a nice introduction.
Sir, voice is not coming.
Am I audible now?
Yes. Now you are audible.
Good afternoon, everybody. Respected sir, professor, Government Engineering College Buxar. So today my topic is recent railway track which is used in Indian Railways, our railway. So these are here we start. This is a basic typical railway structure which include our rail, ballast, formation, and natural subgrade. G for gauge, and C denotes stage. So these are a basic railway track structure, and here we go through about each component of railway track structure. First, we talk about G, that is gauge. In railway, there are mainly four type of gauges: narrow gauge of 2 feet and 2.5 feet, meter gauge, that is 1 meter, standard gauge, and broad gauge. Standard gauge is used in metro railway. Rest of the three gauges are used in Indian Railway. And in these three gauges, two are obsolete, which is narrow gauge and meter gauge. Currently, Indian Railway is basically running in broad gauge, which is 5.5 feet. Here are some glimpses of various gauges in 1947, its share, and currently in 2020s. Here we can see the all meter gauges have been converted into broad gauge and narrow gauge. And those narrow gauge which are conjured are normally UNESCO World Heritage, so it will be preserved and continue as narrow gauge. So the idea for choosing broad gauge is basically it's better loading gauge, improving track utilization of space. In India, normally we have less area, so utilization of that area we consider broad gauge as our balanced economy growth purpose. So in broad gauge, Indian Railway has been divided into four sections: Group A, B, C, and D. Group A for higher speed, that is Rajdhani route, which is speeds up to 160, then 130 of sub Rajdhani route, and Group C for subsection metro, subsection Mumbai, Delhi, Chennai, Kolkata in metro cities, and Group D are rest of the. In NF Railway, normally we compromise Group C and Group D, Group B and Group D railways. And my recently completed project, Araria Gallia New Line project, is comes under Group D for speed up to 110 km/h. So basically, the component start from subsoil, subgrade, then over it blanket, up to blanket. Our formation is being ready, and we put on ballast above it, which form that ballast blanket and subgrade form our track foundation, and above it the track structure are formed. And my part of work is basically related to track structure, that is sleeper and rail. So basic thing about rails is normally we study in railway engineering. Here are some glimpse about it. The, what are the function of rail? Rail provide normally continuous and level surface for the movement of train, a path for very less friction as compared to other transportation medium, and transmit the axle load to the sleeper and then after ballast. In the past railway, we have used a double-headed and bull-headed railway, which can be seen here, double-headed and bull-headed. And those two sections are absolute nowadays. And flat-footed rail is standardized in Indian Railway nowadays. And in flat-footed rail, there is a various development has been done in recent in initial days. We used a 52 kg rail and 60 kg rail. Now recent three type of rail section have been generated: 60 EI, ZU 160 and 136. These are higher grade of higher section of rail, which can be seen its per weight of per kg meter 73 and 68. We used 60 kg per meter of rail nowadays for our broad gauge. Here are some photos of different type of rail section. This one 52 kg, next 60 kg. Yeah, this one is 60 E1, and these are 68 kg rail. This is ZU, which is a synchronized rail profile, which is used in turnout, which is corrosion, which provide resistance to corrosion. So standard rail section we use is 60 kg and 52 kg for maximum potential speed of 130 km/h. And loading according to it is 25 ton axle load, which is maximum axle load. In DFCIL dedicated freight corridor loading, which is 32.5 ton, minimum rail section is recommended for 60 kg. And to find out the rail, there is rolling mark on the way of each rail, from where we could easily find which type of rail has been used on the track. Here are some properties of 60 kg rail. In short, its actual weight, cross section, and service line, and permissible speed up to it can be used 160 km/h. Since our group A has been classified as up to 160 km/h, so in India Railway we normally use 60 kg rail section. Rest of the above section, which is 78 kg running meter rail, is in development phase. So, and to connect each rail have been rolled in 13 meter, 12 meter, 26 meter. So these rail are joined with some fish plate, which provide a level of top surface and gauge face in and provide lateral and vertical stiffness to the rail joint. It also provides some expansion and contraction due to temperature variation in between the rail. And why its requirement? So that is provide elasticity equal to that of the rail. Normally, if we only fix the rail on the sleeper, without the joint is, then it will not allow expansion and contraction, and the gauge will be destroyed. That's why rail joint is important. Here are some points about its requirement. There are various type of rail joint we are using in railways. For example, supported, suspended, bridging, semi-supported. And these joints are fixed with standard type of fish plate and jogger fish. Fish plated, which is normally used in normal rails, and jogger fish plate is used on somewhere fracture happened or welding. Here you can see the ordinary fish plate is normally 1 meter long, 610 long. Jogger fish plate. Combination fish plate is used for different section of rail. Further, we can see and we get some. Here we can see this is combination fish plate. This is 52 kg section and 60 kg section. These are combination fish plate. It is jogger fish plate used at welding area. These are 610 normal fish plate, jogger fish plate. It is 1 meter long fish plate which is used in LWR laying, long welded laying, and in SWR short welded laying. Basically, this 1 meter long fish is used nowadays. Rest of the plate are obsolete nowadays.
Rakesh sir, your slide is not moving. It is in the first recent railway tracks.
Sir, I have shared the screen and I have shared the screen.
Yeah, you have shared the screen, but in the screen, it is coming first slide. So probably you are on the third or fourth slide. Am I right, sir?
Oh, sir, I am on the. This one is.
Just go on the left hand side. Yeah, click on that. Click on that, sir. Yes.
33 number slide. Sir.
Yes. Oh.
Now it is okay, sir.
Now it is okay. It's 33 is coming.
Yes.
Okay, sir. Proceed, sir.
This 610 fish plate. Previously on wooden slipper, it is used. So different this fish plate have been joint by a different type of fish mold. Here there is a picture of different type of fish mold, and these are two standard type of fish mold: RDSO T8199 and RDSO 1509 with 25 dia and 140 length. This one and 115 length. This one. It is used for 1 meter fish plate and 610 fish plate. So the third component of railway track is sleepers, on which rail is placed to form a railway track, and these sleepers are generally transferred to the rail, and its main function is basically to hold the ride in fixed condition, to maintain proper gauge, and to give the line a better alignment, to maintain its backing underneath the sleeper, provide a proper firm and balance support to rail, and basically transfer the load from rail to the wider area of ballast underneath. And it also acts as a elastic medium between rail and ballast, and also provide longitudinal and lateral stability to the railway track. So initially in railway, we were using wooden sleeper, metal sleeper, which are obsolete nowadays. In wooden, we use untreated and treated sleeper. Then after metal sleeper comes into effect, CST9 sleeper and steel channel sleeper. Not that steel channel sleeper which is used in bridge. and then after concrete sleeper have been there. So wooden sleeper, yeah, this is wooden sleeper, which can, this one is a dead end, means dead end area of a railway track. Here we can see wooden sleeper, which are banned in railway now, and considering their advantages, it were used on the track for easy to lay, relay, lifting and maintaining, and best for track circulating area in station yard, and it's simple fittings for railway. But due to disadvantages of its wear and decay due to bombs and not maintaining gauge, it can easily, the track can't easily fix on it. So, and its service life were also very less as compared to concrete sleeper. So that wooden sleeper is banned. Then after CST9 sleeper were introduced, which were used in couple form. Each one is used on each rail. This rail, this is 69 sleeper, 69 sleeper, and it's connected by one tie bar. It has some advantages about wooden sleeper, but now
Rakesh sir, the slide is again static. So if you select the left side and then continue, then I think it will be moving.
Yes,
Just like this.
how it is okay.
every time.
Every time.
Ah. So thus this CST9 sleeper, we can see it's a steel sleeper. Steel sleeper were also good as compared to wooden sleeper. Uh, the rail can be easily fixed on it, and rail have sufficient bearing area on the sleeper. These metal sleeper act as a beam, so it is sufficiently heavy for stability of track. But the disadvantage about it is it can't be used in station area, that is track circulating area, and fittings are required in great number, and due to its metal, it's liable to rusting and corrosion. So metal, they still CST9 sleeper and wooden sleeper were obsolete, and now in Indian Railway we use only concrete sleeper, which is a PSC sleeper, three-stage concrete sleeper, and steel channel sleeper over girder bridges, and fan shaped sleeper, turnout sleeper in yard. Concrete sleeper initially were of two types: twin block and mono block. Twin block were connected by a tie bar. Here it can be seen, this one tie bar. But this tie bar got damages. So this twin block sleeper is not used nowadays. Only PSC mono block sleeper is used recently, and it is designed for 15-ton load for BG. For MG, it is not procured nowadays. Its grade have been increased. M55 grade concrete, STS wire of 3 mm dia of 18 numbers is used during its reinforcement. So various advantages of concrete sleeper found, and with its long service life, durability, and elastic fastening system for maintain good track geometry, and provide good longitudinal lateral resistance for SWR, and better longitudinal and lateral stability to LW. It also has anti-threat properties due to its heavy weight of around 230 to 330 kg, and flat bottom provide better mechanized maintenance, and in track circuit also it well suited. So concrete sleeper are best suited for AWR CWR track, and one type of sleeper, that is 60 kg sleeper, can be used for small rail, that is 52 kg rail. And different in different area, different type of concrete sleeper have been procured. For example, point and crossing zone, different type of sleeper, CJ, guardrail. Further, we can see mm, only disadvantage if we compare about wood, that it is less elastic. But only one disadvantage cannot justify its other advantage about wooden sleeper. So it's we use concrete sleeper nowadays. Here are some disadvantages about it. Its scrap value is very less after using, when it get resorted or disintegrated, then it can't be resell. Here it is a comparison of wooden sleeper, steel, cast iron, concrete sleeper, about considering its weight, service life, handling, track circuit, uses, scrap value, maintenance cost, and fast. Here is a lot of concrete sleeper, block sleeper. It is a basic cross-sectional area of a concrete sleeper. It is end cross section. It is a center cross section, and this one is the rail seat cross section. Here we can see at rail seat, its height is 210, and in middle 180. Width is also 211. These are fitting ERC, which is insulating, rubber pad beneath it, below the rail, and this one is insert to fix it. It is twin block system. It is used in foreign railway, not in Indian railways. Twin block. Here are some main feature of this concrete sleeper. This is very basic sleeper. Normal PSC sleeper, its length is 2.75, 26 weight, and various service life is 50 to 60 years. These PSC sleeper are manufactured according to RDSO IRS P39 code and IRS P45 for turnout. New design have been also tailored by RDSO for DFC for M60 grade of concrete.
Next one.
Rakesh sir, again it is static.
Left click कर देना.
Sir, just click on the left side again and again.
Yes. Now it is
Don't share so much.
Once the slide changes, just click on that.
okay.
Okay, sir. Okay, sir. Now it is.
Some special concrete sleeper are shallow pre-stretch concrete sleeper and special sleeper DFC road. And in recent we use wider sleeper as compared to normal sleeper. Wider sleeper RDSO T8746, which is some correction in the 8527 sleeper. There are some detail about shallow sleeper, level crossing sleeper, CG sleeper, different type of concrete sleeper. There are some info about it, just for info purpose. In level crossing also we use different type of concrete sleeper. This is SEJ sleeper. This one SEJ RDSO 84146. For bridge approach, different type of concrete sleeper we use, excluding girder bridges. In girder we use HB. For turnout, different type of sleeper. Again, in what 1 in 8.5 turnout, 1 in 60 turnout, 1 in 12 turnout. For different rail section, 52 kg, 60 kg, we use same type of turnout. There are some detail about it for 52 kg rail section and 60 kg. 4865 for 1 in 8.5. And for 1 in 12, we use 4 to 1.8. In this one 4 to 1.8. We use for 60 kg slipper 4 to 1.8. These are RDSO drawings of basic ordinary line slipper, RDSO 2495 and 2496 for 52 kg and 60 kg slipper. This one is wider slipper 8527 wider slipper, and here it is again correction in the 8527, and we use 8746. We in the recent project we use this wider slipper due to since it can be used for both rail in small rail and large rail, that is 50 kg rail, 60 kg rail. For both rail it can be used using different fittings. So advantages of wider slipper as compared to normal slipper due to its increased rail seat area. Increased rail seat area resulting higher rubber pad in below the rail. It's like so its width and weight providing higher frame resistance against buckling, chances of reducing distress temperature with likely reduction in rail and welding. So wider slipper is the first step towards the increase of speed in any low speed section. When we planning to increase the rail section speed of that section, then first we change the old sleeper 2496, that is normal sleeper, and change it to this wider sleeper. So it provide heavy resistance and less weld and rail fracture above. And its higher base area also provide adequate factor of safety. Total stresses a rail set and center section of PSC sleeper brought down to and improve its life. Also, heavier sleeper provide more longitudinal and lateral stress to counter higher thermal force on account of rail. Also, longitudinal forces like traction and braking exerted by heavier trains, it can bear. So basically, wider sleeper gives a safe structure as compared to normal sleeper. First, we have gone through rail. Now we use 60 kg section, and in sleeper we have used wider sleeper for higher speed rail section. Here we can see the difference between normal sleeper. This one is normal sleeper. This one is wider sleeper. Difference. Here it is comparison in between normal sleeper and wider sleeper. This first one is normal sleeper 2495, 2496, old concrete sleeper, and this one is recent wider sleeper. Its grade of concrete is STL high tensile strength, initial P stress into its manufacturing, axle load, weight, everything has been improved from the old concrete sleeper. In curve, another type of concrete sleeper we use here. We can see for normally our gauge is 1676, but in curve the gauge has been increased up to 1681. So for 1681 gauge we use this 3670 and another for 1675 7779 huge.
Sir, slide is not moving. Click, just click on it.
Ah, I'm doing it.
Yes, chat in the similar.
In a similar pattern, just change the slide again and again.
Here we can see different type of sleeper on curve, how it can be used. Here gauge is increases by, this is 1675, 1676 and 1679, and here 1681. Traction portion and circular portion, we use different type of curve sleeper. Now the number of sleeper for a particular length of rail we call it sleeper density. Initially, it is described as m plus 4, m plus 5, where m denotes length of rail. For example, if m is equal to 30, means 13-meter rail, then 17 number of sleeper for 13-meter rail will be m plus 4 density. But in the case of LWR, for long welded rail and continuous welded rail, it is expressed in sleeper density, that is number of sleeper per kilometer of track. Normally we use this type of sleeper density, number of sleeper per kilometer of track, in recent nomenclature of rail, and that sleeper density basically depends on the maximum permissible speed of the section, that is traffic density. There are three type of sleeper density we use: 1340, 1540 and 1660 number of sleeper per kilometer. And what is the criteria of choosing sleeper density? Based on the route, for A route, B route, C route and D route. For main line we use 1660 density, for loop line 1540 density, and in siding and loop line we used 1340 density also for low temperature zone area, and 1540 for other. When siding or MPS resuming increased to 50 kmph, then we use 1660 also in loop line. And to connect the rail with sleeper, we use fastening to connect the rail with sleeper. This is the component which together form the structural between rail and sleeper. It also transmit force from rail to sleeper and maintain track gauge. Various forces applied on fastening: vertical forces directly from the wagon, and lateral forces, normally due to parasitic motion of rail, lateral forces. Normally lateral forces is usually very high. Now it's maybe 1 ton, 18 to 20 ton, and all these vertical and lateral forces has been damped by fastening. So this fastening should be enough able to withstand lateral forces without any axis lateral movement or gauge retroaction. Means our gauge would be uniform. That type of fastening we use in our Indian Navy. So rail fastening transmit all the forces via to sleeper via firm connection. So if it is not possible, forces will increase to such an extent that the rail will overturn or sleeper will be crushed. So this fastening is very important part of track structure. It also absorbs some vibration due to cyclic loading, that is dynamic loading, and due to shaking of entire track assembly, the fastening get loosened. Also ballast packing below the sleeper get loosened, and toe load of elastic rail clip also get loss. Track entire track assembly gets disturbed and wear and tear of the rail occurred. Some general function and requirement for fastening is to absorb rail force elastically and transfer to its sleeper and damp vibration and impact and to retain track gauge and rail inclination. Mm, Two main parameters are resistance against deterioration, that is weathering and dynamic condition, and longitudinal forces to resist it, rail creep and contact pressure. Contact pressure comes from toe load. So different type of fastening we use. First one is rail free fastening, second rigid fastening, and third is elastic fastening. The rail here it is rail free fastening. On the girder bridge, edge beam sleeper, we use rail free fastening. Normally, it only provides lateral stability. Longitudinally, it is free. So it also called zero resistance fastening system for beam. Only no resistance on longitudinal movement of rail, only lateral support. Also provide vertical stability to rail and higher degree of resistance for overturning of rail. No component is left loose in zero load fastening system. This one is rigid fastening used in wooden railway, not nowadays. So now we move to elastic fastening. Elastic fastening is used on concrete sleeper. Here we can see concrete sleeper. This is dog spike fixed fastening. Here it is rail elastic fastening, normally used in concrete sleeper. This one is elastic rail clip. Here it is liner and below it rubber pad. So three essential components of it. The elastic rail clip, main objective it is sufficient and continuous toe load on the rail under static and dynamic condition to ensure no separation between rail and rubber pad, to ensure minimum uplift under percussion wave, and also provide creep resistance, that is against a movement, and always to connect the rail with rail in any loading condition. So objective of elastic fastening is to distribute load uniformly, absorb damp and high frequency, provide insulation, increase frictional resistance to longitudinal and lateral movement, and no separation between rail and pad under dynamic movement. So then second one is liner. Liner, its function is distribution of toe load over large area of rail. Normally ERC is, if we don't use liner on railway during elastic fastening, then ERC will at pinpoint contact. So to distribute load over large area, we use liner. Liner distribute the toe load over some larger extent of rail. It's also allow flexibility for use of different rail section, permit gauge adjustment in curve portion, and to align correct the alignment. Also provide insulation. So different type of rail liner are used. Here we can see how elastic fastening work. This one. This is the sequence how we prepare our railway track. First subsoil has been formed, then ballast, then sleeper. Then above it we put rubber pad. Now rail has been placed. This one is liner. Now we put on ERC, elastic rail clip. And when any loading, when engine cam, the load get distributed. First 60% have been measured by this elastic fastening. Rest of the 25 absorbed by ballast, and rest of the 15 gets into the cornice. Here mechanism of its absorbing shock, its vibration and loading. So various third type of clip type pendulum clip ERC. Here component of elastic fastening. So some commonly used ERC and its some properties are here. ERC J clip for joint rail, Mark 3, Mark 5, and anti-theft. We use Mark 5 sleeper 5919, which has 1.2 to 1.5 kg payload with higher deflection, and range of this is range of tire 23 years. Yes. Mark 3 before Mark 5 we were using Mark 3. In point and crossing unit turnout we use Mark 3 also. And zero tow load fastening system of bridges we use Mark 3 ERC, and in normal track we use Mark 5. Inscription have been stamped on ERC to find out its manufacturing date and other thing. Here this one is J clip for joint rail. Tow load in case of ERC, downward force on foot of rail caused by fastening is called tow load. It depends on relative position of ground, bolt hole, shoulder, overshot, and rail safety level. It provides longitudinal distance of 15 km, and in case of large axial force in rail, fastening remains intact and slipper move in velocity. Tow load is requirement in LWR theory, and it's if we consider tow load, why it is ensured. For example, Mark 3 has tow load of 100 kg. So on 4 sleeper, it causes 4000 kg static load. Considering 0.5% of friction between rubber pad and rail, this provide resistance up to 200 kg. Average sleeper to ballast resistance 1000 kg. To measurement of tow load, we use this two types of tow load measuring instrument. This one is mechanical, this one is electrical. Mechanical type and electrical type. Rubber pad normally used to absorb shock and vibration, isolation of rail, increase frictional resistance for longitudinal lateral movement, and transfer distribute load uniformly over sleeper. Uh, it also provide higher creep resistance, reduce noise level, and increase service life of all the track component. So two type of rubber pad we use, pimple pad and groove. And this pimple is not used nowadays. We use only groove. Groove is 4 type of thickness: 4 mm, 6 mm, and 10 mm. Rubber pad, if we use plain slipper, its tendency to slip from the side under vibration. That's why we used groove rubber pad, which help in lateral expansion, higher deflection, possible thinner pad, and greater resilience and distribution of shear force in groove rubber pad. Here we can comparison of we can see about comparison of solid pad rubber pad and groove rubber pad, which provide a very less deflection on the for same type of loading condition. So you can see for better performance of rubber pad, top side should be harder and bottom side should be softer material. So that's why we use composite rubber pad material, where top layer is hard and bottom layer is soft, which is called groove rubber plate, sole plate, and composite groove rubber sole plate. These are some specification about it. CGRSP. In a railway, we use a nylon cord, reinforced GRSP. Here are some commonly used GRSP in Indian Railway. And some common use rubber pad are this one. For wider sleeper 8746, we use 8747 rubber. Here are ISO drawing of this 10 mm thick CGRSP. And now we come to the another railway fitting, which is liner. Liner are fittings used in conjunction with rubber pad and rail on both sides of rail to achieve correct alignment and gauge to provide for correct deflection of ERC, so that for which that ERC is designed to load. That's why liner is very crucial part of rail fitting. These liner are of two materials, glass filled liner and metal liner. TFL liner, glass filled liner, which is used in track circuit area, that is station and yard, and metal liner in block section, in normal section. Cut liner used for J in rail joint. So previously discussed about liner, that is functionally distribute tolled area over large area, and its requirement is basically due to proper slope to match the rail with rail foot slope, and vertical leg of liner should fit properly between rail and insert to maintain its gauge. These are some liner ISO drawing number which use. You can see this is metal liner and this is GFL liner. Metal liner we use for wider slipper. We use for wider slipper 8746. For wider slipper, we use GFL liner this 31 and metal liner this. Some modern fastening used in foreign countries are this Nabla fastening and Oslo fastening. Nabla is used in basically Europe and not using in our. Yeah, some correct. Some information about it. This is Nabla fastening system. Here we can see in Nabla fastening uh, can be used any type of rail, and we just put screw on it. It is spring required to load. Here we can. Now, and this is Oslo fastening used in Germany. German railway. Rail. These two fastening is used in European countries. So then we come to our last, gone through our rail, sleeper, which is basically the material in normal track, now tunnel decks, all in all route we use this stone ballast. Previously, various type of ballast were used: sand blast, maroon blast, coalesce, broken stone blast. But nowadays we only use 50 under size broken ballast for all type of rails. Here we can see the ballast on formation top. Yes, this ballast is different from this one is creep ballast and shoulder ballast. This one is shoulder ballast. So the main important function of ballast is to resist vertical and lateral longitudinal forces, provide elasticity and riding comfort, absorb energy, reduce formation pressure, to facilitate track geometry in correct, also provide track drainage, provide voids for better drainage, level and hard bed for sleeper, and transfer and distribute the load along with lateral and longitudinal stability and maintain the level and alignment. It also inhibit vegetation growth, absorb airborne noises, and provide adequate electrical resistance. So the ballast would be tough and wear resistance. It should be hard without getting crushed under moving load. Cubical shape, resist attrition, should be durable, and provide good drainage of water. And also it should be cheap and economical. That is, it would be locally available so that economical burden will be less. So various ballast profile is recommended in our manual, Indian Railway Permanent Way Manual, for different type of track. And for minimum formation width for single track is 10.5 meter, for double line 13.16 meter. These two width of formation is recently used for single track and double track. On curve, we provide some additional width on the sails, which is clearly mentioned in Indian Railway Schedule of Dimension (IRSOD) about extra clearance on curve. The sails would be, in any case, minimum sails width of 97 shall be ensured on both sides of curve portion or track. Here is a ballast profile of long welded rail, single rail line on pre-stress country sleeper. These are A, B, C, which will be further denote about it. These are A, B, C, D parameter. And here the quantity used per meter, 2.58 in straight track and 2.61 in running track. This one, other than for SWR track,
Yes, sir.
2.282.
We have to go for conclusion of, I think the time is over and we have one quiz in this day. So we have to tell the participant how to attend that
And
quiz.
yeah,
So
okay.
I think we have, you can take 4 or 5 minutes and conclude this session.
So for double line, and the minimum ballast cushion we use in all new line is 350 mm. We use for higher speed, for speed of above 160 kmph. Total 350 mm ballast is provided. In siding also 300 to 350. Then the last part is formation. Formation we can see is prepared with earthwork, means locally available earthen material. We
Slide is again not loading. Oh, oh,
two type of formation we used, embankment and cutting. Normally, cutting is formed in the forest area where embankment is not possible, and embankment is urban area. Currently, we our all project is basically based on embankment formation. So, basic formation is provide a smooth and uniform bed for laying of track, transmit the load, and facilitate drainage and stability of track. Distribution of stress as we seen further from 15 to 25% of total stress beared by formation. So here component our formation form this blanket, subgrade and subsoil form our formation. So now we move further. Here are some component, some terminology related to our uh, track structure. This track formation it says and side slope. And above the for the subsoil we put blanket that. So now we move further to our, this one is some width of formation, and here we go to our another track structure part, turnout. Different type of turnout, that is which permit movement of train from one track to another. Its speed is limited to 15 kmph. Now it has been increased to 13 kmph for one interval. Means diversion of train from this one is main line, this one is turnout. Here we can our maximum parameter speed follow, and in turnout we
sir, can we conclude this session? Rakesh sir. Rakesh sir, hello. Rakesh sir,
follow
sir, voice is coming.
loop line speed 15 to 13 kmph. It compromises
Rakesh sir,
turnout, right hand
Rakesh sir.
switch, left hand switch. Okay, okay. Yes, yes, yeah, Doctor Shinan sir.
Uh,
I am concluding
can
it,
we
right?
Okay, okay.
Here are some component of turnout, and basically there are various terminology, and due to shortage of time it is not possible to describe each and every component. So we move further about this various component. Curve switch, this one is crossing body which is used to in turnout. This is acute crossing, and this one is diamond crossing. This is CMS crossing, and this one is weldable CMS crossing, which we are using nowadays in Indian Railways. It is continuous rail, about 6 meters. Here you can see there is no fish plated part in between crossing. Now we move our speed potential on the crossing, point and crossing. There are some RDSO drawing of different type of crossing. Now we move to the track consists of curve. We all know that curve is a crucial part of our railway track, which comprise various parameters. We just move to our main topic. These are to eliminate all the joints. We use welding on the rail. There are two types of welding: AT welding and flash butt welding. AT welding is weaker part of the track, so we avoid it, and we use flash butt welding, which have same property of rail, that is an strength about 90% of parent rail. Yeah, this is AT welding. Now we move to flash butt welding. This one is flash butt welding. This one is depot flash butt welding, and this one is mobile flash welding. In our project, we use this mobile flash welding, and here rail is being welded on the track with butting, that is pressure, and it forms a good type of welding which have same about 90% strength of parent rail as compared to AT welding, which has only 50% of rail. So our target is to provide a jointless track in all the section. So flash butt welding is recommended by railway in all the new and upcoming project. Various parameter of flash butt regarding its measurement and inspection also here described. And when all the smaller railway have been welded to form a railway length more than 250 meter, then it's called long welded rail, LWR. And LWR have two properties. At the end, non-breathing land, at the end breathing land, and in between non-breathing land, which is non-movable, and end part is breathing land, which is movable. And this LWR is separated by switch extension joint, which provide a gap for this movement of LWR. So in yard, normally we in all the girder bridges, the track is marginalized by SCJ at the end to make it SWR. But in recent our project, we continued LWR through the yard also. That is in point zone also. We remove the all the six plated joint and make it continuous welded drill.
Rakesh sir,
Yes, sir.
Rakesh sir, because of the time
Sir.
constraint, since our another session is there, that will start from 5 o'clock.
Okay, sir.
Okay.
Okay, sir.
So please
I'm concluding.
conclude within 1-2 minutes. Please conclude, sir. Then questionnaire is there. If any of the participants want to ask any question, किसी को कोई question पूछना होगा, वो आपसे कुछ question पूछ लेंगे, sir. ठीक है. Although we know that since you are actual working in the platform,
Sir.
actual workers,
Okay.
industry peoples,
okay, sir.
are.
Let me complete, sir.
Okay, sir.
This one is RDSO CT48, which is on this topic we are working in our project. That is through the LWR in between the station. Normally, the LWR is separated by this station yard. So we try to remove all the joints, which include ACJ and welding in single rail. So this RDSO CT48 we implemented in our this BBganj and BBganj Kaliaganj station of Araria Galia project in NFL. In other zone also, this CT48 is implemented. For example, Western Railway, and NCR also. Here, this point 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All these area previously were fish plated, not jointed. This one is point zone crossing body, and this one is switch assembly. Now we welded it continuously to make it CWR, continuous welded rail in the yard. For it, we used WCMS, weldable CMS crossing in the point. So, and since it is welded, so ACD is used to detect its creep movement in the point zone. Here it is. This one is U clamp and this one is T clamp, and we use at 7 mm gap we install it, and we measure its creep. These are assembly of ACD anti-creep devices used on switch and tongue rail, and we measure its behavior by using creep post. Here it is creep post as ATS, and in between crossing body to measure its creep, means its behavior of movement. These are pro forma our measurement. Various progress on different railway zone. Okay, sir. Another topic we will discuss in another. I am closing it now. This speed raging will be, maybe if I got opportunity later, then I will continue it. Okay, sir. Thank you. Thank you, sir.
Rakesh sir.
Yes, Jitendra sir. Yes, sir. Any question about it?
Rakesh sir.
Yes, sir.
Audience, if you have any question, you can comment in the chat. And Rakesh sir, I'm audible.
Yes, sir. You are audible. In chat question.
Dear participants, if you have any question, please write in the chat box, or else what we will do, we will provide the Mr. Rakesh Sahu sir mail ID to you. You just ask the queries to him. Definitely he will answer every question. We know that any industry people, if they are coming, their lectures are little bit longer, but since they work by their experiences, that is coming. Industry people, since they are working with everything they are working, so practical knowledge is there. That's why they are explaining each and everything very elaborately. And sir, you have explained the things very nicely. Your session is very informative. Complete GEC Buxar, Government Engineering College Buxar thanks you. And from this ATAL
Thank you, sir.
FDP.
It's my privilege to give a lecture in this.
Yes, sir. It is very good and informative session, sir.
Thank you, sir, for your
Thank you.
presentation.
Should I close, sir?
Okay, sir. Any
Participants, if
question will be
yes, if any
welcome from
question
my
is
side.
there, we will provide you, sir.
Dr. Jitendra sir will also provide my contact number. Anyone can directly ask me question about the railway track and recent any
Definitely,
things.
definitely, we will send you, and we will ask your mail ID and send to the participants also. Okay, sir.
Okay,
And
sir. Thank you, sir.
participants, your participants, we will start from next session. Dr. Ajay Kumar sir, he is from NIT Delhi, sharp at 5 o'clock. So for them, please be on the time. And next, your
That is the last.
that is the last session, and that is 6:30, from 5 to 6:30, and 6:45 your valedictory session. Hardly it will take 2 to 3 minutes. We will conclude within 6:45 to 6:50, followed by 8 o'clock your quiz will start. 5:59, 7:59 for 1 hour. Okay, thank you, sir. Thank you. Rakesh sir, thank you, sir.
Thank you, sir. Thank you. Thank you so
Thank
much.